Okay, folks, so this is a video on the final exam study guide. I'm going to go through it partially on this page and partially on a different page so I can show you some work. Okay. All right, so let's start with number one, the molecular formula. We're looking for the molar mass of aspartame, the artificial sweetener. So I have a chemical formula here. The chemical formula is C14, H18, N2O5. So to find the mass, we're going to just look on the periodic table and figure out what our masses are. Now we have 14 carbons, which are 12, plus 18 hydrogens, which are 1, plus 2 nitrogens, which are 14, plus 5 oxygens, which are 16. Add all that together, about 294 grams per mole. We just got that straight from the atomic masses on the table. So just to remember, we get this from over here, this goes to here, this goes to here, and this goes to here. Remember, this small number 5 indicates how many oxygens that we have. Therefore, we have to multiply that by each atomic mass of oxygen. Number 2. Oh, hold on. This is answer C. Number 2. Which one is a combustion reaction? Well, combustion reactions are very simple. They have a CH or a CHO plus an oxygen, yielding the CO2 plus H2O. Now, this is always a combustion reaction, so something that we have to memorize. So the answer here is C as well. 3. Which one is a combination reaction? Well, A plus B yields C. That's a combination. Therefore, our answer here, C. Number 4, which one is decomposition? Well, we have decomposition is A that goes into B plus C. That's a decomp. And that one turns out to be D. Here we go, looking for the mass percent of carbon. Well, in CH4, carbon is 12, and there's one of those, plus 4 times hydrogen, which is 1, for a total of 16 AMU total. Now, of that total, 12 is carbon. Hold on. Let's do that better. 12 is carbon. That's about 3/4 when we reduce, which is about 75% carbon in methane. And that's pretty much how we do mass percents. We do what we're looking for. We're trying to find over the total in mass, and we multiply that times 100%. Number 6. Similar question. PbCO3. What is the mass percent of lead? Might be better. Well, lead is 207 AMU. Carbon, that's 12, plus 3 times 16 for the oxygen. See how I have 3 of them times the 16? Add all that together, 267 AMU. And what percent of lead do we have? Well, we have 207 AMU of that divided by 267 times 100% equals about 78% lead. Awesome. Moving on. 7. What's the mass of acetic acid? We have CH3, CO2, H. And you might see a pattern here. This is 12 plus, we have 3 times 1 here, plus another 12 plus 2 times 16 here, plus 1. Add all that up, 60. Awesome. So I think I forgot to add in some of the answers here. I'm sorry. So number 5, the answer was A. For number 6, the answer is E. And for number 7, the answer C. All right, 8. Zinc perchlorate. So, very same thing. What is the mass of this compound? Well, we have 65 from zinc, plus now I have 2 times 35. Remember, this 2 here gets distributed to both of these. So I have 2 times 35 for chlorine, and I have 8 times 16 for oxygen. Add all that together, 264. The answer is B. 9. Pb NO3 lead nitrate. Pb, that's 207 plus 2 times 14. Remember, this distributes across. 2 times 14 for nitrogen, plus 6 times 16 for oxygen. And all that together, I get 331. So that's my total. Now I'm looking for oxygen. Oxygen, well, there's 6 of them, each with its mass of 16, divided by my total. And that times 100% is about 29% O2, 29% oxygen. Excellent. All right, moving right along. Number 10. So let's see here. Number 10. 1 mole of anything we're referring to stars, people, magnesium, gold, whatever. 1 mole of anything is a specific number, 6.02 times 10 to the 23rd. So with that being said, everything is the same. 1 mole of anything is always the same. The number is always the same. So that's letter E. But there is a difference when it comes to mass, because even though these are different things in the same amount, they all have different weights. So remember that different things weigh different. So we check our periodic table. We realize that gold is 197 AMU, and that's the heaviest. That's D. So a little bit of stoichiometry. When we come to stoichiometry, we always want to start with what's given. Always. So we're given 1.80 moles of SO2. And 1 mole of SO2, notice the units on the bottom are always the same as what's on the top. 6.02 times 10 to the 23rd molecules. And that's what I'm trying to find, is the number of molecules of SO2 in this many moles. Use my fancy dancy calculator. 1.08 times 10 to the 24th molecules SO2. That's letter D. Same thing, a little bit of stoichiometry. 1.36 grams magnesium nitrate. Now that mass is 148.3 grams in 1 mole. Multiply that, or divide these two, and I'm going to get 0.0917. There we go. And that will be answer E. What are we given? We're given 3.55 moles of magnesium, and I have a molar ratio of 2 moles of magnesium to 1 mole of oxygen. Now this is the molar ratio, and we get this because we see the word needed. Needed or produced tells us we need to compare the molar ratios. We get those numbers from the balanced chemical equation. Divide 3.55 by 2, and we get 1.78 moles of oxygen that's needed. That's letter E. .55 moles of lithium are given. We have a molar ratio of 6 moles of lithium to 1 mole of N2. That also equals 0.0917 moles N2 is needed. That's letter C. Cool, so that's half of the study guide. Go through, here are some notes for it, do it over again, check your work, go through, ask any questions, ask a friend, whatever you need, and email me if you really need to. I went pretty fast, so go through and pause and look at it very closely. Shoot me an email and I can expand on anything that you need me to. Otherwise, that's it for this part 1, and I'll see you for part 2.